This video is going to give a quick rundown of the International System of Units, also known as the SI system. Typically, we think of this as the metric system, but there are slight variations on what is considered metric versus the International System of Units. For chemistry, we have a bunch of base units. So we have mass, which is kilogram, distance, which is length, that's in meter. Volume is in liter for chemistry. We'll talk about that in a minute. And time is in seconds. Temperature, Celsius or Kelvin. And for chemistry, also we will be using the mole, which we'll get into later. Derived units are going to be things that are comparisons of more than one metric unit. So they are kind of a created unit based on a fundamental unit. So you have area being meters squared, density being a comparison of the mass and the volume, molar mass being a comparison of the mass to the mole, molar volume being a comparison of moles to liter. So it's always kind of involving multiple units in their comparisons. For metric prefixes, this is the way I like to explain it. You, I'm sure, have seen other ways where there's like negative exponents. I like to just put one with the larger unit and then count how many smaller units make up the larger unit. So you'll see above the base unit, which is liter, gram, seconds, meter, etc., we have the larger number going with the base, because as we look above the base, all those units are bigger. So as I said, I put the one with the larger unit. So 1 terabase is going to be made up of a bunch of smaller base units. 1 gigabase is going to be made up of a bunch of smaller base units, and so on. Once we get below base, those are all smaller than base. So therefore base would be the biggest one, and it would be made up of smaller other units. So 100 centimeters, for example, would be equal to 1 meter. And that is kind of the key as we are going to set up conversions for this in the future. Going back to mass, the SI unit for mass is technically the kilogram. However, in chemistry, we tend to measure things that are much smaller, so we will be using the gram, which is equal to 1,000 kilograms. Typically, mass and weight are kind of used interchangeably, but they are meaning different things. Mass is based solely on the amount of matter in the object, so how many particles it's made of, while weight relates to the gravitational pull on that matter. That's more of a physics differentiation, but it is important to know that mass and weight are not the same thing. Distance and length is in the unit of meters. 1 meter is about an average doorway length, close to a yard in terms of English units. We tend to use, if we're going to be measuring centimeters or millimeters or even smaller things in chemistry, again, meter and kilometer and things like that are more for physics. But we will be using, in a lot of cases, more centimeters or millimeters to measure various things in chemistry. Volume is a tricky one because there is the liter, which we use in chemistry, which is metric, but it is not actually the SI unit for volume. The SI unit for volume is a derived unit, so it is a cubic meter. And for chemistry, we're measuring a lot of liquids. So using the liter is much more beneficial to us, but technically that is not an SI unit that is recognized for volume. 1 liter is equal to 1,000 centimeters cubed. You don't need to know necessarily that the cubic meter is the SI unit for volume. You just need to know that liter is the one that we will be using. And the last kind of important one here that we'll be getting into is temperature. So temperature in Celsius is based on relative melting points of and boiling points of water. So 0 and 100 is set as kind of freezing and boiling. And that was created specifically that way, using water as the reference. And so all Celsius temperatures are in relation to water. They're not actually related to any sort of physical aspect of the substance itself. So that's where Kelvin came along and gave us an absolute scale for temperature. This scale is measured based on particle motion. So if the particles were not moving at all, that would be 0 Kelvin. As they start moving faster and faster, the temperature would increase. There is no negative on the Kelvin scale, which is why it is kind of necessary, because although Celsius and Kelvin relate to each other very well, you can have negative Celsius temperatures, and when you're doing calculations and things like that, that becomes an issue. The last thing I want to discuss is derived units. So derived units are combinations of quantities measured, as I kind of alluded to before. We will be getting into some derived units, but typically it's a comparison of SI units. Realistically, you can do derived units with anything you want to compare, but it's typically related mostly to comparing our kind of SI units. And that's just a quick intro into the metric system.